we start this session, I'm going to give a short introduction. So, as Ryan mentioned, I'm heading our community and developer relations. And for us, joining OpenSSF, the Open Source Security Foundation, and Cloud Native Computing Foundation last year and a couple of years ago was a natural step for us. Both these foundations are driving and leading important efforts when it comes to securing software and open source software. And we wanted to contribute in a sort of meaningful way to these processes. So by being a part of these ecosystems and being able to collaborate with industry peers, we're not only strengthening our own solutions, but we also get the opportunity to help and support enterprises and also other open source projects to implement the security standards that we know are so important for the future of trusted and reliable software. So one of these collaborations that we started last year was with the company Chainloop, and that's why Miguel Martinez is here. And they are also a member of OpenSSF, and we also support their mission, and that is basically to support enterprises or help enterprises in delivering software secure and compliant. So you hear that this relates back to the presentation before the coffee break, faster, through automation, and with transparency. So this session is about software supply chain security, and we will also dig more into the data and metadata that is so important part of the whole supply chain security and how to manage and secure that data. So over to you, Ben.
Thank you. Thanks everybody for being here today. Today Miguel and I are going to talk to you about supply chain security, but first, if I can get this to work, there we go. We're going to talk about cake. So what are the steps one might go through when it comes to making a cake? You're a chef, you've got a set of ingredients, you're going to go through a set of procedural steps, and at the end, you want to eat some delicious cake. What happens if a bad actor comes along and adds an ingredient into your cake? Or maybe they add something extra after you've already done the mix. Or maybe a supplier provides a package that you thought was good, but it's actually bad. Or maybe we don't have the most trustworthy chef in the world, and they swap out the ingredients with some of their own. So this has gone off the rails. We want to eat some delicious cake, and at this point, we're not even totally sure what we've made. And that's what we want to talk to you about today, is knowing what goes into the cake and what goes into the software that you're creating as part of your CI/CD pipelines for your customers and also for those that you are taking in as an organization. So why are we talking about this now? Supply chain attacks continue to grow. The speed and pace of development, the containerization of applications, you're pulling in hundreds of dependencies for any given software project that themselves have second layer dependencies. It becomes very difficult and complex to manage very quickly. And in addition to that, it's everyone's favorite topic when it comes to compliance and regulations. There have been different executive orders talking on the need for organizations to be able to attest to maintain a certain level of supply chain security. There's some frameworks from NIST on how to go about doing this and also from the industry. And there's also the EU Cyber Resiliency Act that goes into effect in a few years. So what are some of the challenges today? So, development teams, like I was saying before, are managing hundreds of dependencies for a given application. Compliance teams are trying to keep up with these changes. You're trying to manage this vulnerability information. We've just built this version of our application. What are the vulnerabilities we're susceptible to? What other dependencies did we take in? Do we know where they came from? Do we know if they contain vulnerabilities? And then do we know if these even impact the way that our application runs? It can be a lot to manage. But I'm here today to tell you it's all about the data, which is a mouthful to say. So there's thankfully a nice word for that, the metadata. And what I mean when I talk about metadata in this context, it's things like software bill of materials. So if we go back to our earlier example, this is the recipe for our cake. What went in? What was the ingredients list that went into our application? What were the binaries? What versions were they? Vulnerability reports, scanning like a container image. What are the vulnerabilities it contains? What's the CVSS score? Which of these do we need to be concerned about or worried about for our application? License information is the software that we're using. Are we licensed to be able to use it in a way that our application is using that application or that binary? And then, attestations and being able to do self-attestations to say, we went through this set of procedures and processes to create this application. On the subject of metadata, it's important to you're able to trust the metadata that you're generating, because metadata that you can't trust can be dangerous. So if you imagine you have application B, good application A, bad application B, if you were to swap some of the metadata, software bill of materials, maybe a vulnerability that got listed in one for the other, then you've got a problem. And that's why it's important to sign and protect not only the binaries that you're creating, the executables, the DLLs, the container images, but also the metadata that goes along with those, the software bill of materials, the vulnerability reports, licensing information, other procedures and steps that were taken to produce that artifact. And signing this act of creating digital signatures is a step in almost all of these supply chain frameworks, whether it's the ones from NIST or SALSA and others. And Miguel is going to talk to you about some of the steps you can take in his organization to implement those tools.
Thanks, Ben. So there are indeed a lot of open source tools out there today that can help you to generate and to secure and to store metadata today. So for example, you can use Sift to generate the software bill of materials, the list of ingredients that Ben was talking about, and then later on you can use Gripe to generate a vulnerability report based on those ingredients or those components. You can also sign binaries. In the previous talk, we were talking about signing binaries and signing container images. You can use cosign in combination with Sigstore Suite or with combination with Keyfactor sign server. But, and there are many other tools that I'm not talking about here. Before we were talking about static composition analysis, and that, for example, that could be SEMGREP and other tools that I'm not putting here. But on the metadata front, what I want to highlight are one framework called SALSA, that is a set of practices that tells you a different set of requirements to secure your software supply chain. And underneath an open source specification called Intoto, that is the component, the foundation of what we call software attestations. And the software attestation is this foundation to secure any piece of metadata, any piece of evidence. Piece of evidence like software bill of materials we were talking about, or vulnerability report, the static composition analysis report, anything. And the idea is that it's a general purpose document that can add any additional context about a container image that you're building, or about a step in the software delivery lifecycle. So for example, in this case, we have an attestation that is adding information on a container image. It's adding an SPDX software bill of materials, for example. But the important part here is that this document is signed. It is signed, and which adds the authentication and tamper resistance properties that we're looking for. So if we put all of that together, this is a traditional CI/CD pipeline you might have in your organization today. And usually what happens is you have developers or the traditional DevOps teams that are adding a set of tools in different stages. So you might be generating a software bill of materials at build time, and then attesting it and storing it in an OCI registry. And then before going to production, you might be run it against Open Policy Agent, which is a mechanism to run automated policies on that metadata, on that software bill of materials to check, for example, for licenses. Or use 3B to double check vulnerabilities before going to production. But you can imagine that in an enterprise, you don't have one of these. You have hundreds of these, and you have thousands of products. So there are many challenges that appear with this approach. This developer approach, in which developers have been in charge of implementing these security and compliance practices themselves. And what happens is that in the enterprise, you might have many tools, not 2 of them. You might have 50. And they might be used in different ways. They might be generated in different formats of metadata. They might be run with with different options, which adds, at the end of the day, a lot of fragmentation. So you might have a lot of fragmentation in your software supply chain before. Before we were talking about fragmentation on signing. That's one example. It's a fragmentation on the practice of signing artifacts. You also might have data silos. You are generating all this information, this provenance information in your software supply chain, but where is it? Can you use it at the end in an audit process if you need to get a holistic view of how you're building software? And then can you trust the metadata? Can you make sure that has the qualities that we are expecting to have? If you're building software bill of materials today, as an example, you might be encountering that there are many different formats and different qualities or properties that they might or might not have. So you have lack of visibility on all those practices, and what I showed before was just the happy path of compliance and security, because it was just generating a software bill of materials and a vulnerability report. But in an enterprise, security and compliance still has a lot of manual processes. There are different stakeholders today that have a saying on how you build software, and a lot of this might be a manual QA report or an architectural review before you go to production. And you need to bring this to the system as well. And of course, while you do this, you bring more compliance and security requirements, you add more friction. You add more friction between teams. So that's why we believe that an evidence store is the foundation for automated compliance. What we're talking about here is about reaching compliance automatically, so you can deliver software faster. And an evidence store is a system that allows you to collect metadata from any source, any CI/CD, any tool that you might be using today. This system will make sure to attest that metadata, add those authentication properties, sign in that metadata, so make sure that you can trust it. Because later on, what you're going to be doing is running policy checks to make sure that you can meet external and internal frameworks, like the NIST framework or internal frameworks that you might have. And another important aspect of this system is we need to make sure that we take into account that there are different personas in this software delivery lifecycle process. So now you have security, you have compliance teams, and you need to give them a way to separate the boundaries and to make sure that each one has clearly their boundaries. So security can define their policies the same way the compliance, but developers should have a very easy way to comply with it. So if you put it together, as you can see, there is not much difference. And this is on purpose because this is from the point of view of the developer. What we did to the developer is to hide the implementation details on how to gather that metadata, how to sign that metadata, where to store it, or how to run policies with it. And I believe that.
Yeah, so I just want to touch quickly on the integrations that we've done with Chainloop. So using eJBCA, we're able to support like ephemeral certificate key issuance using the Chainloop CLI. So you're able to sign these attestations that you're generating, SBOMs, vulnerability reports, container images, and then attach all of that into an OCI registry to go back and verify later. And then we also have an integration option with Sign Server, using it as kind of like a key management system, the hardware-backed HSM for doing signing, again, using the Chainloop CLI. So there's a lot of flexibility there with the deployment. And it brings me to something I kind of want to bring up here in that, when we talk about enterprise digital trust, a lot of times we're talking about TLS certificates, machine identities, which is absolutely a big part of PKI. But a lot of organizations, if you already have PKI present, you have a foundation for enterprise trust, you can leverage that and get value out of that by deploying it in these other use cases within your organization that people don't often think of. So when it comes to supply chain security, that could look at things like SSH certificate issuance and management for developers to be able to access remote build servers, remote machines, using role-based access controls and key management for products like Signum, certificate issuance and signing for Command, eJBCA, Sign Server, being able to issue certificates out to the developers in your organization or to those CI/CD pipelines or to CLI tools like Chainloop to be able to sign and then store that in the Chainloop evidence store. And also things like Kubernetes Kubernetes workflow identity management that I think there's a talk about tomorrow that I think will be really interesting. And in conclusion, we wanted to just say that the metadata that's being created is important. It's just as important as the application itself that you're building. And also that there's a lot of tools and frameworks out there to help organizations get started with this. So whether it's Salsa or something else as a place to kind of begin this journey, or the journey for maybe different teams in an organization can sometimes be at different levels. And then finally, the ultimate goal and objective here is you want to be able to deliver secure and transparent software to your customers in an automated way that lets you know, what went into the cake, what went into the application that you made and delivered. So, thank you.
So I have a couple of final questions for you here, sort of. So, I mean, it was obvious from this presentation that it's not only about securing the artifacts themselves. You don't have to be so far away from the artifacts themselves. It's a lot about sort of securing the data and metadata, the proofs around it, sort of.
Yeah, that's right. So, I mean, there are two reasons for that. One of them is there are more and more compliance frameworks, especially around software supply chain security. So actually last week, OpenSSF released OpenSSF Baseline Security, which is a framework to try to map with the external requirements like CRA and others. So there is more and more, there are more and more requirements based out of metadata, machine readable metadata, like the one that we're talking about here. And the second one is part of this, we are raising the bar on the quality of that metadata, making sure that, especially if you sell to the government here in the US, you have this concept of self-attestation in which you are taking responsibility on how you're building software or the components, the vulnerabilities that you might have, and now you need to make sure that that metadata is correct because you're taking responsibility on delivering that software to your customers. Yeah. So it's very important to make sure that you have more automated metadata, more like machine readable metadata. You gather more data, and that metadata is trustworthy.
Because that's really the evidence that, or the data that someone will take a decision on based on if they will run this software or not, sort of at a certain point in time. Sort of. So that's really needs to follow all the compliance rules.
Correct. It's not longer about the artifact itself, the container image that you're building, but how you're building it. So, and what were the processes involved in it? And things started with software bill of materials. That's a small example. But there is way more behind that about securing the build pipelines. They mentioned it before. But even when you go to an enterprise, you have processes in place about the QI team, the legal team. How do you, at the end of the day, that's metadata that you need to make into a system like this to make sure that you can take responsibility on the software that you're delivering.
So we also heard here that pipelines are getting more and more complex. What do you think is the next sort of big trend that will help us really to manage these things without losing our minds?
So the fragmentation I was talking before, I'm a developer, I'm guilty of this. A lot of it happened because of DevOps, the way that DevOps was being done. We pushed the responsibility to developers, and we started doing all these security practices, done by developers. And the problem with that is you end up with the Wild West of practices and tools. But now, what's the answer? The answer is something potentially in the middle, and something I'm seeing right now is this concept of platform engineering that has been trying to first make sense on path to production, how to go to production when you're building software, giving all this automation to developers. So basically taking that role about DevOps, more standardized. But now they're bringing all the security and compliance requirements to those platforms as well. So a lot of users of Chainloop, they come from the platform engineering front, that basically they're trying to shift down compliance to developers on top of a platform like that. So I think platform engineering, taking all these compliance requirements and shifting them down, it's a next step.
That's interesting, because that's been one way of us also interacting with Cloud Native Computing Foundation, where there's a lot of platform engineers, and where we've seen that their security awareness, as we also heard from Ellen a little bit from the IT space earlier, are not always the best. So that's also where we see that we can contribute as a vendor in that space and also together. So, Ben, maybe, if you're an organization that are early in their supply chain journey, what do you think what could you recommend as sort of the first steps to get started?
It's a good question. I think for organizations, some of the frameworks we were talking about, Salsa is a really good one that has a series. I think there's like level 0 to level 5. And as you move up, from each level, you're adding more steps, more security to the process. But being able to start at that first level 0 and just kind of getting a baseline understanding of what your different teams in your organization either are doing, maybe some people are doing some things, maybe others aren't doing anything, and just kind of getting that overview of where you're at, and then being able to work in, again, those lower levels of the frameworks that have maybe easy steps, so maybe Salsa level 0, it might not even involve signing a piece of metadata, but it just involves, could you generate that metadata? Does it exist? And then maybe the next step, the next level is, okay, now let's sign that metadata. And then maybe the next step is, okay, now let's have that build be totally reproducible or something like that, or totally sealed off from outside access and control. And so there's different levels that make it easy to go through and implement if you're just getting started.
Okay, thank you. That was our last question for today. Are we early?
Yeah.
Thank you.